Hello students, this is the video number 11 for the third chapter Laws of Motion part D, 9th standard physics. In this part we'll discuss Newton's third law of motion. Newton's third law of motion. In first law, we studied that if the body is in state of rest or in motion, it needs force, because in the absence of force, the body will not change its state of rest or motion. In Newton's second law, it explains about the magnitude of acceleration under the influence of the force applied on the object. But how the force acts on the object, that was the failure of first and second law. So that we'll discuss under this third law. According to the statement of this third law, to every action there is always an equal and opposite reaction. So in simple words, if there is action, there is a reaction also. Action and reaction, they occurs always in pairs. So in magnitude action and reaction both are equal, but in direction, action is negative of reaction. The direction of action is always opposite to the reaction, or vice versa. The direction of reaction is always opposite to the direction of action. So number of examples are there. For example, if the body A is moving towards the right side, left to right, and the another body B is moving from right to left. So when they will collide, after collision, they both will move in opposite direction. This will experience FAB, and this second ball will experience FBA. So both FAB and FBA are the forces, but interesting thing in this is FAB is equal to minus of FBA. Why? Because we have already discussed that action, if it is action, this FBA is reaction. So action and reaction, they both are equal. Equal to sign means they both are equal in magnitude. Negative sign shows that their direction is opposite. Direction is opposite. So different examples we have. Example number 1, a book on a table. A very simple example. Suppose if this is the table, top surface, and this is the book. So its weight is acting downward. Book weight is acting downward. That is action. mg is its weight. That is action. And reaction to this is in opposite direction. That is in upward direction. That is what? Reaction. So very interesting part is, what is the net force? Is it 0? So 0 is the wrong option, because this is very important part, that action and reaction always act on two different bodies. They do not act on same body. Just like action is acting on table and reaction is acting on book. So book and table are two different things. Book and table are two different things. For example, pushing a wall. If I'll exerting a force with my palm on a wall, so on wall I am exerting a push. So that will be action. Action is acting on what? That is wall. And simultaneously wall is exerting reaction on my palm. So they never cancel each other. Again I am repeating, because they act on two different bodies. Firing a bullet from a gun. That is also important example. Firing a bullet from a gun. So bullet is moving in forward direction. That is a action. And the recoil of the gun will experience a backward force. That special name for that reaction force is recoil of gun. So recoil of gun will act in opposite direction. Bullet is moving in forward direction and gun is recoiling in backward direction. In third example, we'll consider the rocket motion. As there are again two forces are acting. One is the force on gases which are exhausting through this nozzle in downward direction. So this is the force on gases. Force on gases. So that is what? Action. Action. Action is acting downward in this way. And there is a force on rocket. Force on rocket. On the expense of fuel, this force is acting in upward direction. So rocket on the whole will act under the influence of this force, will move in upward direction. So again the same thing, that action is acting in opposite direction, which is equal in magnitude. So number of examples are there that again you can study deeply, thoroughly from the book and relate with this discussed part of D video number 11. Okay, thank you very much.